This is 2.1 dealing with the topic of functions. In real life, we always talk about and things that depend on one thing depends on the next, and whatever it is, it could be weather, it could be height, it could be whatever it is. So here's two illustrations. So like the height, if you had a graph, your doctor, your parents probably have this documented. So if at age, so this first graph right here, so at age, this is your age, didn't write that, but that's your age. So age 5, you can see how tall you are. At age 10, how tall you are, 15, 20. So notice the height is dependent on the age. So however old you are is how high you would be according to this chart. And the same thing with temperature. So this is the temperature of this is the date of a certain month at a certain location. And so the 5th of the month, the 10th of the month, the 15th of the month, and you can see the temperature. It's dependent on whatever day it is. So let's say the 10th, notice it's like literally at the 10th of the month, we can see the temperature is right there. At the 15th, we can see the temperature is right there. And so literally it's dependent on what you have it to begin with. It's dependent on the date, the temperature is, or the height is dependent on the age. So if you start talking about functions, a function is dependent on one of the input as well. So a function is a rule that assigns the x in a set to exactly one element in set B. And I want to emphasize exactly one in set B. So a function f, and again, we just label it f or g or h, just like we have names, functions have names as well. We typically use the letter f for function. So a function f assigns it to f of x. So notice my little box I have down here. This is a function box. So whatever this function is I have inside of here, I'm labeling it f. And then I'm going to put a certain value x in there. And I'm going to put it inside the function box. And then another value, the output, is going to come out. And again, that's the y, the input and the output. And we often label that the f of x. So in other words, we put x into the function f, and what comes out is f of x. That's really what we're talking about. You have an input and an output. The output is dependent on whatever you put inside. So set A is the domain. So I could have a lot of x's over here, okay? I could put another x in, a different type of x. Like this would be my first x, this would be my second x. I might have a third x. And I'm going to be putting them inside the input, inside the function. And every time I put an input in, an output is going to come out. So notice I have for the domain, and this is my set of domain. That's what comes in or is being put inside the function. It's the input. We often label that as x. It's also the independent. Independent means you get to choose the numbers that you want to put in. You want to put in 5, you want to put in 15, put in negative 37. Whatever the input is, you're going to put that in. And then the dependent doesn't really have a choice. I mean, whatever the function is, the input is going to go into that function, and then the output doesn't really have a choice. You just calculate it, and that's why it's dependent on what the input, the independent variable is. And all of these values that's going to come out here is the range or the output. All right, that's the definition of a function. So let's look at an actual example. So here's a function f of x equals x squared plus 4. So I have this function right here, and that's really what the function box is. And I'm going to put some values in. And again, you could typically you guys are used to your input as your XY chart. So your x's are your input. So I'm going to literally put in -2. So if I drop a -2 inside that box, evaluate that, what's going to come out is an 8. Now look down below, another way to represent that. We typically represent it as an XY chart, but this is also called a mapping. So this is your input or your domain. And so when I input -2, out comes +8. So it's literally mapping it. So that's really what this does. It maps it from one number to the next number. It's the input. And of course, if we wanted to graph that, that would be the point -2, 8. Those Those are points that we're doing. The input, the output, the x and the y. So this is your x. This is also your f of x, also called your y. Right? So same thing if I put -1 in, 0, 1, 2. Every time I put a function in, a number into the function, another number is going to come out. So -1 is mapped to 5, 0 is mapped to 4, 1 is mapped to 5, and 2 is mapped to 8. Now something I want to point out, notice the definition. Every input does go to only one output. Again, go back to the definition. Exactly one element. So 1A, input in set A, your input, each value has to go to exactly 1 in the output. And 2 does go to just a one number. 1 does just go to one number. So every one of those goes to one number. It is a function. So let's look at an example. So again, here's mappings. So the same thing, if you look, does 2 go to one number? Yes. Does -5 go to one number? Yes. 3 go to -3? Yes. Does 0 go to 5? Yes. Yes, it is a function. Now look at this other example. Is it a function? Well, 1 goes to 10. 2 though, notice 2, when I put 2 in, I get 20, but if I put 2 in again, I get another value, which is impossible. You cannot do that. So that is not a function. And you can see it on the mapping. So if I ask you to evaluate this function, and again, just imagine, and you have the function 3x squared plus x minus 5, and you're inputting f. This is the correct notation, f of -2. So you're literally you're putting in -2 into f. So what's going to come out is f of -2, which equals, and then we're going to evaluate it. And then the same thing with 0 and 4. We want to find that out. But this is the correct notation saying I am putting -2 into the function f, and out comes, and that's what I want you to evaluate each one of those. So when we put -2 into this function, -2 squared plus -2 minus 5, we're going to end up getting 5. And the same thing when I put 0 in, I'm going to get -5. And when I put f of 4 in, I'm going to end up getting 47. Again, these are points, so we would have to graph the point 4, 47. We would have to graph the point 0, -5. And we'd have to graph the point -2, 5. These are all points. So let's talk about a piecewise function. A piecewise function, like here's the function f of x, and it's like x squared is the function if x is greater or equal to 2. If x is less than 2, then we're going to use this function. So here, if I say evaluate f of 3, well, notice f of 3 is greater or equal to 2, so we're going to literally plug it into that function, x squared. So that would be 9. F of 0, notice it's less than 2, so that we would use this one right here, and we're going to literally plug 0 into this function, and we're going to get -1. So a piecewise function literally is two separate type of functions based on its description that is given. Now, one slight definition I need to give you, well, it's not a slight definition, but it's, every once in a while they'll ask you for the net change. So the net change, like between 3 and 0, so notice f of 3 is at 9, and f of 0 is at -1, so you're literally going to find the difference between those. So 9 subtract -1, so the difference is 10. And you can see that on the chart, by the way. If you actually graph this, you can actually see the difference, the value between the y range. This is 9 high. Remember, this is the 0.39, right? And this is the 0.0 -1. So you can see the difference on the y. There's a 10 difference. It's the net change. All right, so if I actually had to graph this, notice what we want to do is, and I'll just assign this as my red, okay, and this is my blue. And so really what you want to do is create like an XY chart for your blue, and then create an XY chart for your red. And notice the red is greater or equal to -1. So we're just going to put -1, 0, 1, 2, 3, whatever numbers we want to plug in that's greater than -1. I will explain this. We do want to plug in -1, even though it's supposed to be greater than -1. And then this says x is less than -1, so less than or equal to. So -1, -2, -3, -4. And we're just going to literally plug those values in to each of these functions. And just keep in mind that the red function is -2x plus 3, okay? And we're going to plug those values in. And the blue function is x minus 1. Just got to keep track of that. All right, so I went ahead and plugged those values in, got my XY charts, I graphed them. So if I started connecting these and noticing what they are, notice I do want to emphasize this is greater or equal to -1. So at -1, it cannot be a closed circle. So this has to be an open circle. And then this is the line, or I guess the ray, it's going to look like that. And then at -1 here, see, it's actually a closed circle. And you're going to be graphing that. So the piecewise function literally looks like that, and that is a function. All right, so if I wanted to evaluate these problems right here, notice I'm not substituting numbers in, but on here I'm substituting in anything. Remember, your input is anything you can put in. So here, if I substituted A, I would literally put A, exchange the X's for A's. So this actually becomes 2a squared plus 3a minus 1. That's it. Now here, if I substituted it for -a, so I'm going to get 2a squared minus 3a minus 1. And again, notice here, I'm taking that whole thing and I'm going to substitute right where the x is. I'm going to substitute in an a plus h. So I went ahead and multiplied all that out. I do want to emphasize this to you again, because again, just want to remind you, a plus h squared, you have to write it out twice and FOIL it. All right, so I did all of that. This is your final answer here. All of that is what, when I substitute a plus h in, this down here is what I get. All right, and again, you might want to pause the video to follow those steps, make sure you understand how I got that. That's actually an important concept that you're going to be learning later on as we go through this math course and even the next math course. All right, so let's look at what if I wanted to evaluate this problem right here. So notice what I have. I have f parentheses a plus h minus f of a all over h. And I did that. If you go back to the problem we just did, I did all of those problems. It's just a matter of putting it all together. So notice I just rewrote it, what I did on the previous screen. So this is what I have at the very beginning. I have f of a plus h is all of this. And then I have my f of a is all of this. Now, something I do want to point out that some students make a mistake on, make sure when you minus f of a, you put these things called parentheses on. Because if you don't, you won't use the distributive property and you're going to make a big mistake. So let's go ahead and use the distributive property and add like terms. So once you do that, you get this expression. And then I want you to notice that something, you have h divided by h. So they all have an h. So we're going to basically take that out. So 4a plus 2h plus 3 would be your final answer for calculating this. And then finally, if we start talking about the domain, we've already discussed this in class, but just as a reminder, the domain is the set of inputs, okay? So, you know, in some cases, you got to look at this, like, what is the domain of this problem? And notice, I want to emphasize what can't x be? So if you notice, x cannot equal 0 here. So it's all real numbers except 0. Same thing here, this would be all real numbers except x cannot equal 1. And this one right here, remember, you cannot have a negative number inside the square root if we're talking about real numbers. So this would be all positive numbers. So x is greater or equal to 0 would be the domain for that function.